Recording has started. Hi everyone, welcome to ML System Design. This is third session, but no, second design session. This is on Google Street View blurring system, and this will enable privacy protection by blurring the faces and car license plates. So, Jaymeet Vasava, our lead for the study circle, AI ML study circle, this is his third presentation, and he will walk you through the various design aspects, the model aspects, and the 7-step process we follow for the ML system design. And so, welcome. He's an engineer, excellent engineer, and has 4 years of experience, and he should be able to guide us through the various design aspects as well as other aspects of it. Welcome, Jaymeet, and I will hand over to you. I'll go into silence mode. We are in the recording. Thank you very much.
First of all, thanks a lot, Prakash, sir, for the introduction. Hello, everyone. Welcome to the ML System Design third PPT, as we started from 00. So this is the third PPT, and this time our our discussion is about Google Street View blurring system. As we all have seen that Google blurs the images in the street view of people as well as the number plates of vehicles. So how Google does that? So first of all, just a quick explanation how Google actually creates the street view. It captures the panoramic image of the route that we are going and then stitches them all together in order to create a whole 360 interface in order to navigate through the routes. So as we have been following a particular framework for designing a system, and depending on those our use cases, we will be adding or rather uh, removing some of the steps if we needed it or not needed. So just a second. Yes. Yes. Okay, sorry, my keyboard was not working. So the first step was clarifying the requirements, designing a street view blurring system which blurs the human face and license plates. BO, that is business objective. Business objective is to protect user privacy. We will also be using training data set of 1 million annotated images of human faces as well as license plates. Though 1 million is a big for a normal person, big database of 1 million images is a big thing for a normal person, but uh, for a company as huge as Google, it's not a huge by any aspect. So so now, as we have clarified the requirements, we have to translate those requirements. And by the way, you can also see in the image what we want to achieve. In the image, you can see the faces of the people included are blurred out, as well as the cars having their license plates being blurred out. Now, after knowing the what we require, we have to translate those steps or translate the business objective into our ML task, which was the second step as we are following the framework. So the second step is framing the problem as an ML task, which is to accurately detect object of interest in the image. After detecting the objects, we can blur them before displaying it to users. So as you can see in the image down below, that all the various objects, by the way, in this whole presentation, I'll be using for the conciseness reason, cars as well as people as objects. So all the objects in the image are being showcased into different boxes. We will call them bounding box, and each of the bounding box have different color code representing different features of the vehicle as well as uh, representing different features of the object included in the image. So if we have a car or truck, we have light blue as well as dark blue, and for person we have white color. So this is what we are trying to achieve, that from a raw image, bounding box with the help of the ML model will be using bounding boxes in order to locate those objects in the image. And before we display it to users, those uh, those parts or faces as well as the license plates are blurred out. So moving further, we'll be talking about the input of the system, which is also the part of this second step, which is specifying the input and output of the system. An image with 0 to multiple objects at different locations within it. The model would detect output and output those locations. So first, there is a raw image, a plain simple image. If there are objects of our interest, those objects have to be located first by the model, and then later on, mm, they are to be uh, first they are located by the model, and then further they are showcased using bounding box. So as you can see, that is what's happening in the image, that the cars are being uh, detected using blue bounding box and people with red bounding boxes. So for doing that, we have to choose a right ML category or the right learning machine learning model. And the machine learning model has to do two things, which is predicting the location of object in the image, where the object lies in the image, and predicting the class of each bounding box. So whether the bounding box consists of a person, a car, or other vehicles per se. So and the first is a regression problem, where the location can be split. The first point, which is predicting the location of object in the image, is a regression problem, where the location can be specified by x and y coordinates. And we the second part is the classifying those bounding boxes, which is a multi-class classification. Generally, the object detections are divided into two parts, which is a two-stage network and one-stage network. So in the two-stage network, we have a region proposal network, which is RPN, and classifier. So as you can see in the image below the two-stage network, and that there is a plain simple image. That image is used, and a region proposal network proposes the candidate regions in the image, and once those candidate regions are ready, those regions are further classified, whether the containing bounding box has a person in it or a car in it or a different kind of vehicles. And the examples of a two-stage network are RCNN, which is region-based convolutional neural network, fast RCNN, and faster RCNN. Moving further, we have one-stage network. In one-stage network, both the stages are combined. Bounding boxes and object classes are generated simultaneously without explicit detecting for regional proposals. So as compared to two-stage network, we work through the process in two stages, and all both of those two stages of proposing the region in the region of the object in the image, and as well as classification of those objects are done in one single stage. As you can see in the image down below, that they are directly classified, as well as they are directly detected as well as classified. So in the one stage, so in comparison with one stage and two stage, the two-stage network performs the operation in two sequential steps, which is slower, but it creates accurate results. For the rest, for this topic discussion, we will be using two-stage network, and we are dealing with a data set of 1 million images, which is not used by modern standards, and modern standards for company for bigger companies, and when the training data increases or the need for quicker prediction arises in the future, we can later shift to one stage. As we are dealing with images, and those images will be not lively used, or not, will not be used in a live manner, we can still work with the two stage though. So after deciding the category for the uh, machine learning model, we have to prepare the data for working with it. So in data preparation, we have data engineering. In data engineering, we first deal with the data that we have at hand first. So we have a annotated data set or a labeled data set where we already know what the output is, and we will use that data set to train the model, as well as we will have street view images, the raw images. So, and in annotated data sets, we have 1 million annotated images with each having bounding boxes and associated object class. You can see their column names and image path having giving us the path to the objects, and objects giving us the what kind of objects do we have in that particular image, as well as the location of the bounding box. So the bounding box is in a sequence of x coordinate, y coordinate, width, and height. But bounding boxes can also be used in the representation of x1 and y1. Yeah, x1 y1 and x2 y2. In street view images, the ML system will process these images to detect human faces and license plates both. So the location is the location where the image is taken. The pitch, your role in the street view image dataset sample, you can see the is the position of the camera. So the pitch defines up and down position of the camera. Your defines left and right of the camera, and role defines tilting your head or the camera towards your shoulder, left and right. So these are the degrees, and based on that, pitch your role is defined. Timestamp are the timestamp when the image was captured. So further moving from data engineering, we have to prepare the data for being taken in as an input, which the feature engineering deals with. So applying the standard image pre-processing operations like resizing and normalization, etc. We'll be using the data augmentation to increase the size of the data. So resizing, as also discussed before, resizing is basically resizing the image in which the ML model is configured to work with. So if let's say any size of 28 by 28 is a configuration of the ML model to work with, then every image will be configured in 28 by 28 size. In normalization is bringing the whole image down into a range where the model will be working with. You can say the vibrancy of the image, or the high vividness of the image containing should be they are brought down in using normalization. in data augmentation, further discussing the data augmentation, adding a slightly modified copies of original images or creating new images from the original image. So as you can see on the image on the right, that there are various predefined settings. These are similar to any of the normal photo editing application that we find. So if we take one image and apply those settings, you can see that there are various different images being formed using one single image. That is what data augmentation means. And images, all those images are later included in the data set for the model to learn the complexity, as well as solving the imbalanced data set, as you can see the points on the right. So the imbalanced data sets are basically sometimes that the data set consists of a minority as well as the majority class. Sometimes and we have and when we deal with the majority, when the model is trained on a majority class, it becomes familiar with it, and is not able to learn the minority class well. And for solving such issues, imbalanced data sets are dealt with in a few different techniques, where we can increase the size of minority class using data augmentation. But we want, if we can, then we can also reduce the size of the majority class by cutting them in roughly the size of the minority class. And also, when we use a data augmentation for images, we have to careful with the settings of rotation, flipping, and bounding boxes, as those have the probability of getting the objects out of the image frame, and we render no use of it. The data augmentation can be done with offline and online. In offline, the training time takes more uh, we have faster training time but takes more storage, as all of the data is with us and we know the what kind of data we have to train the model on. We have the training faster, but all of those images are to be stored on our end, so that is the reason we have more storage. In online data augmentation, we collect the images from the user's end, and only when a useful image from the user is collected, and then only we use that particular image to be trained, to be useful for training the model. And that is why there is slow training time in online, but it doesn't take an additional storage as well. So after preparing the data, we have to prepare the after preparing the data for taken in as an input by the model, we have to develop the model. So as you can see the image on the right, that we are dealing with a two-stage network as mentioned before, and we'll go through the parts of this this two-stage network one by one. So we have a convolutional layer which prepares the feature map of image by taking in input as an image. The region proposal network, RPN, proposes candidate regions, takes feature map as input, and gives candidate regions in the image. The classifier takes the feature map and the proposed candidate regions and assigns an object class to each region. So, so you can see that first the image is taken in as an input by the convolutional layer. Now the feature map is created. Let's see how feature map is created. So for so every image contains certain kind of features in it, which are measured by the use of filters. Now these filters have, depending on the measurement of that feature in the image, gives out a particular value, as you can see in the image on the left. If we place that, uh, the filter is the size of a window matrix compared to the image. So if the filter is moved with a particular stride from starting from top left and going horizontally, the each and every value is outputted on the feature map, as you can see. And after scanning through the whole image, the after passing through the whole image, a complete feature map of this image is created, which is later passed on to the region proposal network, which gives us the candidate regions, which comprises the whole stage one. And in stage two, we classifies those candidate regions and give them to the belonging object classes. After developing the model, it's time to train the model. So for model, the model is expected to do two tasks well, which is bounding the boxes. The bounding boxes, sorry, the bounding boxes are supposed to highly overlap the ground truth bounding boxes, and predicted probabilities of each object should be accurate. So first, so we are dealing with annotated images as well, where we know the what is the output, and depending on that, the model has to predict predict those output which should highly overlap with the ground truth bounding box. Ground truth bounding box basically means the real value of the bounding box, and the model is also the model should also be predicting the object accurately. So for that purpose, we will be using regression laws for uh, as if we used a regression for function for locating the objects in the image, and classification for we used classification, a multi-class classification for classification purposes, which are the loss functions. So loss functions are basically it helps us to measure the accuracy or efficiency of the output, accuracy of the model, and gives us the ac- accuracy of the output. So uh, the in CNN model, we have a forward propagation and backward propagation and loss calculations. Though these are really mathematical operations as well. And so for the simplification of understanding, in CNN, the forward propagation means going from an input layer towards in the direction of the output layer. And in backward propagation, we move from output layer towards the input layer while having the loss, while calculating the loss function. So the loss function basically means the difference between the desired output and the output that the model is giving us. And the loss function is feed it back to the input layer in such a way that we can get the desired output. After training the model, we have to evaluate its whole performance. So generally, the machine learning model has to detect n different objects in the image. So to evaluate the model's performance, we will evaluate each object separately and average the results. So as you can see in the image on the right side, We have dotted boxes which which are the predictions made by the model, and we have the ground truth with the continuous line. And we can see that model has made six total predictions, out of which three in total, three of them are lying on the ground truth values. But how they should be calculated? So the overlap of the ground truth as well as the bounding box predicted by the ML model is to be calculated, or the intersection of both the uh, ground truth or the actual value and the bounding box of the model is to be calculated. So that is what on the right we can see that we have intersection over union. Intersection over union, or IOU, which measures the overlap of bounding boxes, shows the detected bounding box are aligned with ground bounding boxes. An IOU of 1 indicates that they are fully aligned, though it is a rare thing that a model predicts with an IOU of 1. A higher IOU means more accuracy. IOU higher than zero point 0.7 is considered a good prediction for a correct detection. So you can see the formula of IOU, that area of overlap upon area of union, or you can also uh, define the IOU in terms of shape A and B, where where intersection of shape A with intersection of set shape A and B upon union of shape A and B. So the evaluation can be calculated in offline and as well as online manner. So for offline metrics, we can see that, and by the way, these are really mathematical calculations where each contains their own mathematical calculations to be calculated. So for the simplicity of understanding, we'll only go through the why we appointed some and why we didn't appointed some. So in precision, uh, as you can see, it's a correct prediction upon number of prediction. But if we keep an IOU threshold, let's say for example zero point 0.7, zero point 0.5, or zero point 0.1, the value of P changes, which is not something that we want. So we'll not be using the precision. In average precision, we will be measuring the in average precision we will be measuring the single object being detected by the model. So for measuring the precision of a single object being detected by the model, and for models overall performance, we will be using mean average precision of for measuring them overall. So mean average precision will also take into interest that the faces detect correct faces detected by the model, as well as the correct number number plates or license plate detected by the model. And the average precision will only be calculated based on whether a human face, how many times a machine correctly detected the human faces, or how many times a machine predicted correctly the license plates. And those both of those values will be separately calculated. In online metrics, we'll use the user reports or complaints or feedback from the users. So while serving, or we have already deployed the model, when we run an object detection algorithm, it is common to see overlapping of bounding boxes because RPN proposes various regions in the image. RPN meaning region proposal network. So it is important to bring that down to one bounding box. For that, we will use an algorithm called NMS, non-max suppression or non-maximum suppression. So non-maximum suppression will keep highly confident box and will remove the overlapping boxes. So as you can see the image on the left side, that there are various bounding boxes, but only the bounding box with the most confident percentage will be kept. So as you can see that there are two bounding boxes with 98%. So only those will be showed and selected. On the image of on the right also you can see the middle image where the bounding boxes are overlapped on the ship as well as the plane. But after applying the non-max separation, it they are bring that down. They are brought down to one using NMS, and the most confident box out of them is only selected. By the way, this is also how YOLO works. As YOLO was the example for one stage architecture. So YOLO basically, if you can see the three images on the right, the YOLO basically lays down the bounding boxes all over the image, and then later checks whether each of the bounding boxes contains any object in it or not. And depending on those bounding boxes, the bounding boxes, whether they have the object or not, only those bounding boxes are kept. And further, using non-max suppression, the most confident bounding box are kept. So going further, so this is how our whole uh, ML system looks like, where we have discussed most of the processes. So now we'll be discussing the batch prediction pipeline. So we have the raw street view images, the pre-processing. Pre-processing meaning the preparing the image for the model, and the blurring system, which has to do four tasks, which provides a list of detected objects. NMS, non-max separation, gives the final detections, blurs the detected object, and stores the image in object storage. So as you can see in the batch prediction pipeline from raw street view images, with the use of pre-processing and the blurring with the help of pre-processing, the blurring services give us the final output. And if a non-max suppression is needed, with the use of that, the bounding boxes are brought down to one, and and then later stored into the database of blurred street view images for the user to use using the fetching services. So as you can see that the user has a fetching services on the top right, uh, and let's say the user came across an image that he has a complaint for let's say a falsely detected human face or unblurred human face as well as the license plates. So as discussed before that, we will also be using online metric for our evaluation. So online metric for our evaluation. So user can report and give us the report about the image and give us the image that has a falsely been blurred or not blurred. So as you can see on this left side that we have a user report. Using Kafka, we through Kafka, we use use of a hard negative mining. So hard negative mining basically means that we are trying to collect all the images that the model failed to recognize and create a data set out of it. So using hard negative mining, we create a hard data set. A hard data set is combined together with the original dataset, pre-processed and augmented for dataset for increasing the size of training data, and stored in the pre-processed dataset. Using that using the pre-processed dataset for training the model, we use them to train the ML model and give them to learning services for a better improvement. So in data pipelines, as discussed before, we use user reports to collect reports from user, and from hard negative mining, we produce a hard data set. And combining those with the original data set, we train the model to improve the performance of the model. So to summarize the whole presentation, we started first with clarifying the requirements, where we clarified about what system we want to build as, which was the blurring system, which blurs human faces as well as license plate for user privacy protection. We translated those steps into ML learning steps or machine learning steps, where we defined the ML objective. We specified that the input and output, which is a raw image, and the output, and the input is the raw image, and output is a blurred face, as well as blurred face of people, as well as license plates of vehicles. Then we decided the category of two stage as well as one stage, where RCNN, the region-based convolutional neural network, fast RCNN and faster RCNN being the examples of a two-stage network. In one-stage network, we discussed about YOLO, as well as we discussed about a one-state network, where YOLO as well as SSD being the examples of one-state network. YOLO being you only look once, and SSD meaning single shot detector. So in data preparation, we prepare the data to be taken in as an input, and in data engineering we discussed about the annotated data sets that we have, and the street view images. In feature engineering, we uh, discussed about the techniques used for preparing the data to be taken in as an input. So pre-processing, we discussed about resizing as well as normalization, and in data augmentation, we discussed the data augmentation as well as the offline and online methods and their trade-offs. Then we discussed the model development. We selected the model, where uh, a normal RCNN was used, and we discussed about the convolutional layers, the region proposal network, which is RPN, and classifier. In model training, we as we used regression and multi-class classification. So for calculating the loss function, which is the difference between the desired output and the output that the model is giving, we have to calculate the regression loss as well as classification loss in order to know the evaluation of the output. Or further further going, we evaluated the whole model's performance. We we discussed about intersection over union, IOU. we, and depending on that concept, we discussed the offline metrics, the precision and precision, average precision and mean average precision, and we employed average precision as well as mean average precision for our offline metric. The For online metrics, we relied on user reports, complaints or feedbacks. And while serving, we discussed about the non-max separation, which brings the count of bounding boxes to one and keeps the most confident bounding box on the image. And further, we discussed about the ML system design, the whole picture of our working system would look like theoretically. So we discussed first we discussed the batch prediction pipeline, where we use the pre-processing, blurring services and non-max suppression. In data pipeline, we created the hard data set using hard negative mining, pre-process those images, and used augmentation to increase the size of the data set. And then in training pipeline, we trained the model. And further, we served the user using the fetching services from the dataset of blurred street view images. So these are some of the references that you might use it to further study, or rather learn about the image processing or RCNN architectures and YOLO and stuff for object detection purposes. And these are some of the glossaries that just in case if might have been missed, you can look at it. So thanks a lot, and that's for the Google Street View blurring system. And I'll be going back to Prakash. So thank you.
Thank you very much, Jaymeet. Excellent presentation. I would like the floor open for questions. So we can have some questions and see what needs to be improved or what else we can do. Like your suggestion, Madam's suggestion of Mamta, say that we should discuss about models for ML system design. So that is the one we will cover in next presentation. But here, this presentation on the image processing methodology and the pipeline and various things, you can definitely ask questions to Jaymeet and me. Floor is open. Please go ahead. You want anybody to unmute? I can do that.
Good evening, everybody.
Thank you.
Am I audible?
Yeah,
Yeah,
you are
good.
awesome.
Yeah, good evening, everybody. Uh, Jaymeet, I have one question, and this has always been on my mind. When we talk about data augmentation, right?
Yes.
Uh, uh, Particularly just in a raw form, rather like we do image rotation or image mirror imaging or uh, reversal kind of things, right?
Yeah.
So in that case, in certain kind of data, is it acceptable if we don't understand the data and without understanding we try to do data augmentation? Because like for example, if you take brain image, then
Yes.
right and left brain, if we simply do mirror image, mirror reversal or mirror rotation, then it would go wrong,
Yeah.
right? The prediction also may go wrong. If you supply the wrong input, obviously the output will be wrong. So in that
Yes.
case, how do we first understand the data and also understand what kind of augmentation can be applied? So is there any
So
mechanism or rule for it?
I will be answering the question regarding this use case that we have discussed for street view
Okay.
images. So in street view image, let's say we are on a crosswalk and there are street signs,
Yeah.
whether to walk or let's say the speed limit and stuff. So we can't use a totally upside down rotated image, because we are
Huh.
not going to see that in real life either. So
Yeah.
we can use only certain techniques of rotation as
Mm.
or blurring. So creating a scenario where the possibly the model is able to train in any of the circumstances to recognize that.
So,
Yeah,
but
I
are
would.
there any specific rules for it? Yeah. Yes,
Okay.
No,
sir.
if and so the data augmentation is mostly used for increasing the size of training data. So
Yeah, the
mostly
number of images.
mostly we it's not used, but if it's not used, it also can be like in if we optimize with the feature engineering, we also sometimes remove those features from the data that are least used or least have an effect of training on. So at that time we can also figure out that even if we have applied all those effects, let's say from rotation and blurring and stuff, then we can remove the data that has uh, least effect on the model, training as well as learning.
No, but here the question
So
is not of least
yeah,
effect. The question is it is effective, it is required. But if we simply rotate, if we simply blur, it may give a wrong input. And plus there are some applications where the amount of data already available is very less. So by all means, we will have to perform augmentation if we want to really train the data well.
Correct. Correct. No,
Okay,
yes,
I
so
would say false positive and false negative uh,
yeah,
it has to be measured while ground truth is being looked at.
checked.
So
Yeah, yeah.
it has to be human in the middle who has to decide what data to use and not to use to avoid the avoid
The precision, accuracy parameters. Yeah. Okay.
human in the middle has to decide that. It is difficult with lesser data. However, with a larger data set, we can do it, but with lesser data set, we need to be more human intervention has to be there to be able to select the right set of data that will help. So augmentation is good to increase the data, but does not mean it increases the accuracy or
Mhm.
precision. Have to be human in the middle, have to like the one like feedback which Jaymeet showed, like that we'll have to give feedback saying, hey, this is wrong, you remove this, this doesn't solve the problem, this in fact creates more error. So we have to do trial and error a lot in this case, especially if
Mm.
it is uh, and not only that, if left brain and right brain labelings are there, then we
Mm.
want to make sure that we rather rotate it upside down rather than rotate it.
Left, right. Yeah.
So we'll have to, that's a trial and error. And usually the human element in the middle will be able to answer that. Hopefully, that's the best explanation I can give you. But
Yeah. But that
yeah,
exactly was my concern. The whole purpose of ML is we want to remove human intervention, and that
correct.
is why we are introduced. So that was my whole concern. Yeah.
See, if the data set is large, then one can do it. But data set is not large enough, then we'll have to do some human intervention to uh, make sure that it is more closer. And plus, overfitting, underfitting are there, right? So we neither
Yeah.
want to
Yeah.
overfit. So
True.
we have to give the ability to reduce the false positive and improve the model with whatever metrics
Yeah.
which.
Yeah, sir, I do understand. We do have metrics to test it or check it, but my concern was even before performing the evaluation, we should be able to identify the false positive and false negative.
I think we lost you. Uh, yeah, go ahead. Are you there?
Hello,
Mamta, are you there?
Preeti.
Yeah. Yeah, go ahead. Go ahead. We
I
missed
shall
you for.
I shall mute. Preetida wants to ask something.
Sure,
She
sure,
has
go ahead.
raised the hand.
Yeah, just a second. Let me see if I can mute her. One sec. Sorry. Where is she's there? How do I? Okay, one sec. So Preeti, yeah, I think unmute, right? One sec. Let me see. How do I unmute you? Unmute. Unmute. Yeah, go ahead.
Hello.
Yeah, we can hear you.
Huh. Thank you very much. This question is also in very much line with what Dr. Mamta has raised a concern. I think before, because you already said that you had a 1 million images, something like that. So before that, you need to check that whether your data set is a balanced or imbalanced. If it is imbalanced, then only you go for the augmentation. And as reason has a question has been raised that what type of augmentation? You say you can't make it like where there is a human face upside down or anything like that. Um, and another thing is that there are so many obfuscation algorithms are there. So, are you looking for the blurring the whole face of the human being, or you are concerning with the privacy of the human being because you just have the eyes, which already conveys a lot of message and some type of a biometric illusion also, or you are considering the whole face. So that also needs to be seen. And another thing is that um, when you are using this, so that was my first question, also somewhat very much in the vicinity with what Dr. Mamta has raised. And second thing is that when you already have this CNN algorithm, and then you already said about the RPN and things like that, you try to show also that there is a overlapping, so that there is a vehicle, the person is sitting on the vehicle, so for vehicle there is another color, and the a human face, there is a human body, there is another color. So how you make it unique, unify that thing. But um, are we looking for the images, the whole images, or are we looking for the some specific image which may create some type of a privacy violation? Because image processing, if you do the whole thing, it is going to be very, very heavy. If you are able to detect with some type of a age detection, Kenny or something like that, and saying that okay, only this part is important, then you can reduce your processing requirement. And another thing is also, uh, you already said, because if it is a street, it is a live view, it is not a still view or something like that. So the images are going is going to change very fast. You see, people are walking very fast, some people are walking very slow, and things like that. So per video, if you are already making the still images out of these real time images, what is what type of, how the frames of the video you are going to consider, that yes, this is the frame I'm going to take it in this particular video where I see this human being, and try to uh, fulfill my objective, like the blurring of the uh, uh, information that you are already targeting as a this problem. So this is the second question I have. Because if it is a Google Street image, then obviously it is a live, and
Correct.
images are changing. So let us say we are considering a very small video frame also. So in that particular video frame, you have to have the, you have to chop down that video frame with certain interval, make it very slow, and then you say yes, this is a particular image, I'm video clip I'm going to take it, and there I'm going to apply this thing. So that thing has to be done prior to whatever the process you start for the ML or whatever we say computer vision processing we are doing, and things like that. All right, okay. Thank you very much. You can answer what you can.
Jaymeet,
Yes. So, as I've read for
repeat the
the
question.
study.
Repeat the question. Question one was what? Question two was what?
So the first question of being the Google Street View being live was, as I read it, was it was like a panoramic images are captured first, and then they are stitched together in order to create a one singular route of that street. So, and that way, that is the reason we use images. I hope.
You use images, that is okay, that I fully agree.
Okay.
But are you, because this is the main thing, you are talking about security over privacy over here, that you do not want to reveal the privacy of the human being as well as the vehicle. So for
Yes.
vehicle it is quite obvious, it's a number plate, and
Yes.
this human face is for human it is a face or something. Or if you are talking about
I think we,
Yeah, yeah. Go ahead. Continue answering in the meantime.
yeah, but I thought she was
So,
speaking something and we lost it.
okay, let's wait. So the issue is like you are saying that you are getting a
Yeah.
already pandemic. Yeah, go ahead.
So her question was more before the when the data is being collected, or so she is saying that when the data is being collected, that the images are to be captured in certain manner, that the face is visible or not, and depending on that, the model should be able to blur it out.
Okay, so there is a process. Of course, there is a process. You have to ensure that whatever you do, you cannot cover the entire thing all the time. So you have to reduce the exposure. Like she said, mentioned about eye, right?
Yeah,
If you just clear the eye, your 50% of the chances that person can be identified is taken care, right?
yeah,
So there are certain things which you can, like nose, eyes, ears. So just focus on particular segments of the object to blur them or to alter them or
yeah,
augment. That is one way to reduce the processing requirement. That is well taken. That's a good question and right question. And same way, the other question is also correct. Now we are talking here image. We are dealing as if it is image processing. It is not streaming video,
yes,
right? So, but if there is a streaming video, it has to be like the frame rates, and the
yes,
frame rates have to be reduced in such a way along with the motion, so that a constant image which is overlapping, multiple images are moving, so you have to choose the right image to minimize. So those are two aspects, both are correct and both need addressing. Now how we address it is a issue, and that I think she has also suggested. Actually, she answered the question herself. The question is, what are we thinking? That is what are you thinking? That is what she's asking you. Correct.
yeah. I think at the time of designing, the team would have come up with some of the uh, answers, that what kind of resolution as well as what kind of frame rates to be captured, the to be used to capture the images.
Yeah. Can Preetida, can you take? Are you there? What is happening is
I think she has got disconnected.
okay.
There's some network issue at her end.
Okay, there is some network issue, but let's see if we can text it because she is there, right? Can you hear? Okay. Um, Preetida, can you talk or text? If she can text also,
Yeah,
that
we can take up the question. Yeah.
yeah.
Meanwhile, Amina, do you have any question? She's my PhD student, Amina here.
Oh, welcome, welcome. Go ahead. Yeah, you can ask any question. I will mute, sorry, unmute also. I mean, just a second. Uh, where is the? Yeah,
Hello.
yeah. One sec. How do I enable? Okay, let me see. See if I can get Amina here. Amina, Amina. Okay, yeah. Go ahead. I unmuted you, Amina. She says unmute mic later. Okay. So then put the question if you have anything on text, that's okay. Amina. Okay. She cannot unmute at this
Ah,
time.
yeah, she's not able to unmute. Yeah.
I again unmute. Okay, see if she's able to do it. She must get a prompt to mute, unmute. No? Amina guest will be unmute mic later, it says. Okay. So never mind. If you can't unmute mic, you can text it. You can ask question on the chat. That should be fine. I think she's dropped out.
Even she got disconnected.
Okay.
There's some issue with the Geo.
Okay, that's fine. What we can do is we can have question offline also
Yeah, yeah.
later. But at this time, I think we have a decent amount of information, and Jaymeet can go over it with Amina as well as with Preetida and make sure that he's connecting to them and getting the questions detailed. And also, there are some other things like YOLO. You only look at once, and
Yeah,
SSD, that is the single shot detection. I think those algorithms we need to bring into the fore to discuss so that
true,
people bring, and
true.
also this FC fast CNN, faster CNN. So if we take this model, 5 models, and try to describe them, that is one aspect of it. The other thing which I came to note or which I presented this week was about there are two OpenCV or OpenVINO. These are the Intel uh, hardware specific accelerators which are used for image processing. The other one is
Mm-hmm.
for the NVIDIA. We have got Q CNN, which is nothing but Q is for the CUDA and DNN is for the deep neural networks. So QDNN and other libraries like Metropolis. And so I think we need to have discussion more on the commercial models versus the open source and general paper models. So why certain models are popular. Also, somebody needs to talk about ImageNet and COCO, various databases of image sets, which are used by public. So those are some of the things which came across my mind. And I asked Professor Gokhale if he can do something present in that manner, which will help people to grasp easily. And
Yes, that would be good. Yeah.
so we'll add that while I'm hoping that we'll be able to do the model for ML system design next week, which is what I'm proposing at this time. Let us see Jaymeet how much he can bring to table, and we will address additional things through Gokhale and other people we have like Sayam and maybe Vivek. There are some experts with us. We can ask them to throw light on it because they have done work for some of the commercial folks, right? And those who do
Hmm.
commercial, they have insight into exactly what they did. So we'll bring that
Yes.
to the table
Yeah.
because
One more suggestion I had
go
is
ahead.
we use different neural layers and networks for different types of data, right? Or image. Can we discuss the mathematics which can be included for each of these aspects? For
Sure.
example, when I say
Mhm.
data pre-processing, so which are different techniques for pre-processing? If some mathematics aspect.
Yes.
Correct.
So yeah, because the existing models may not have, but there may be different mathematical approaches to solve that problem. So we
Sure.
can bring those things in between for the existing models also
Okay.
to
Add
improvise the results.
mathematical background, mathematical aspects.
Approaches, mathematical
Approach.
approaches for a particular task. For example, data augmentation. So, what mathematics can be included for rotating the image or inverting the image or mirror rotating the image and all that?
Yeah,
Let's
I think
yeah. For example, this Jemith was talking about overlapping or insertion of images, right? To
correct.
identify which image. So there we can apply something known as wavelet transforms.
Mhm.
Right. So likewise, like what techniques can be applied for a particular activity? Yes, these techniques may overlap. Same thing may be applied for the pre-processing. Same thing may be applied for this image insertion and that. But these are the possible things. So then, if, for example, if I am finding some problem in data pre-processing, I would look into all those mathematical approaches, and if something works for my kind of application, I may try to incorporate in the existing model.
Correct. Correct. So the
So,
obfuscation, overlapping, intersection, whatever techniques are used. So various
huh,
techniques for augmentation and mathematical mathematical approach to doing that.
huh.
Whether you do vector through some tensor flow
Yeah,
manipulation.
huh.
So those aspects are a little bit deeper.
Difficult, yeah, they are deeper, but at least we, even if we have
Correct.
some idea,
Correct.
maybe we don't discuss the exact mathematical aspect of it, but
Mhm.
even if listing is possible.
Correct. Correct.
Okay.
So what I will
Right?
do is we'll try to compile and uh, help Jimmy to answer it, handle it, but at the same time we'll augment our support through our experts who are there in our team
Huh.
to present, make few more presentations to help us in listing those as well
Yeah,
as
yeah.
listing those and mathematical
Right.
background
So
to it.
for example, if I want to do some, like rounding of some image, some edge or something, right? There is a
Mhm.
concept known as contourlet in maths. So we
Mhm.
can use contourlets for all those things. You know what kind of? So we have a round. For example, like we want to work on tumor, and we are not getting the exact boundary of that tumor. So
Mhm.
then we can apply contourlets over there. So
Mhm.
these are different things that can be applied for different purpose.
Mhm. So
At least even if we know the names of these things, that can also help us explore further.
mhm. Excellent, excellent. I think you have good suggestions. We have to deep dive into various aspects and what libraries are available to support that.
Huh.
That
Huh.
could also be another one. Library,
Yes, yes.
because at the end of it, it is programming to do this. So, library to support these models, these
Yeah.
operations, I would put it.
Yeah.
So that would be another aspect of it. Very good. I think we are getting deeper and deeper, and definitely we will look both at commercial as well as open source and the research papers to identify,
Hmm.
bring it to table. And I will still work with Jaymeet because he is the one who is the getting more and more clearer as to what needs to be done. So we'll
Yeah.
build around him, and of course we'll bring the experts also. I'll ask Gokhale to make one presentation to clarify on
Sure.
some of the aspects because he has been doing it for a long time. In fact, he wanted to write book with me. I was telling, hey, I'm not the right guy for this. so,
Mm-hmm.
so
Yeah.
since he was talking about book 2 years back, okay, on this, at
Oh,
that
that's
time,
good. Sorry.
he's,
Sorry.
he's, so he should be able to help us. Okay.
Yeah. So
So,
are you in Baroda currently? For how
no,
long?
no, I'm in Mumbai. I'm in Mumbai at home,
Ah,
and
okay, okay. You mentioned you were in Vadodara. Maybe
no, no,
last time you.
no.
Acha,
Last time
acha.
I was in Baroda when
Oh.
Jaymeet there, so that we I am able to work with him closely. But
Uh-huh.
so we have found a convenient way. He works in the night, so I
Uh-huh.
will just check what he has done and then ask him what's the time, and then
Okay.
we have
Actually, he
got
asked me. We could have met last week, but then I had some workshop going.
no,
So
no problem,
Jamie did drop me a message, but then somehow I couldn't make it. I'm sorry for that.
no problem.
If
I'll be
all
there
three
again.
of us could meet, it would have been nice.
It's okay. We can
Yeah.
still meet sometime, so don't worry. We'll have another session, and then maybe in another fourth, fifth session, I can still be in Baroda. So let's hope
Sure.
that we can do that again together,
Yeah.
and we
Yeah.
might do it even from the what do you call Kalabhavan if that happens. Correct?
Right. Right. Yeah. Jamit, would you like to plan some detailed workshop on this?
We'll see first, ma'am. This is new to me, so
No, no
Okay,
problem.
fine, fine. No problem, no problem. Yeah, no problem.
Let's do
and
one
I
thing.
will
Whenever you're
out.
whenever you're comfortable and sure about it, right? Most important.
Yeah.
Right? Okay, fine. We'll meet sometime this week, Jaymeet, after Monday.
Okay, sure,
I'll let
ma'am.
you know. Right? My workshop is now over, so I mean, I'm not free because lectures are going on, but we can always work it out.
Okay, okay.
Right? Yeah, yeah. Okay.
Okay,
Okay,
so I
thank you,
will
ma'am.
I will close the session with this. Is that okay, madam?
Yeah.
Yes, yes.
So let's
Thank
try and meet
you.
again. Yeah,
Yeah, yeah.
next.
Thank you so much. Yeah, bye. Bye.